Have you ever wondered why you can't know both the speed and position of a particle at the same time? Well, this is where the fascinating world of quantum physics comes in, introducing us to Heisenberg's uncertainty principle. This principle, a fundamental law of quantum mechanics, presents us with a paradoxical reality. It states that we cannot accurately measure both the position and momentum of a particle simultaneously. In simpler terms, if we know exactly where a particle is, we can't precisely figure out how fast it's moving and in which direction. On the other hand, if we know the speed and direction of a particle, we can't pinpoint its exact location. It's a game of give and take, precision and uncertainty. So, the more we know about one property, the less we know about the other. Now, why does this matter, you might ask? Let's explore further. So, imagine you're trying to take a photo of a fast-moving car. You're standing by the roadside, camera in hand, ready to capture this speeding wonder. Now, if you choose to focus on the car's speed, trying to capture that sense of motion, you'll notice something interesting. The image of the car becomes a blur. You can see the car is moving fast, but where exactly is it in the photo? That becomes hard to ascertain. On the other hand, if you decide to freeze the action, to pinpoint the car's exact location in your frame, you're making another trade-off. Sure, you can now clearly see where the car is, but can you tell how fast it's moving? Not really. The image doesn't convey the car's speed anymore. This is a simple way to grasp the essence of what's known as Heisenberg's uncertainty principle. Heisenberg's uncertainty principle, a fundamental concept in quantum mechanics, tells us that we cannot precisely know both the position and momentum of a particle at the same time. Just like in our car analogy, the more precisely we try to measure one of these properties, the less precisely we can know the other. But here's where things get really interesting. You might be thinking, well, we could just get a better camera, right? In the real world, yes, better equipment can often help us overcome such challenges. But in the quantum world, it's not so simple. The uncertainty principle isn't about the limitations of our measurement tools. It's not about our cameras or our techniques. It's actually about the fundamental nature of particles themselves. These tiny building blocks of the universe don't have precise values for both position and momentum simultaneously. So it's not that we can't measure these properties accurately, it's that they don't exist to be measured accurately in the first place. It's as if the universe itself is saying, you can know this, or you can know that, but you can't know both with absolute certainty. In the quantum world, this is not about the limitations of our equipment, it's about the fundamental nature of the universe. So, why should we care about Heisenberg's uncertainty principle? Let's take a moment to consider this. Everything from the chair you're sitting on to the air you're breathing is made up of atoms. And those atoms? They're composed of subatomic particles, protons, neutrons, and electrons. It's the behavior of these tiny particles that Heisenberg's uncertainty principle helps us understand. So, in a way, this principle is fundamental to understanding the very fabric of our universe. But let's move from the grand scale of the universe to the smaller, more tangible aspects of our daily lives. Take, for instance, medical technologies like MRI scanners. These machines rely on the uncertainty principle to create detailed images of the human body. Without understanding the unpredictable behavior of particles, we wouldn't be able to use these life-saving tools. Then there's the electron microscope, a powerful tool that lets us peek into the realm of the very small. This wouldn't be possible without Heisenberg's uncertainty principle. It's this principle that allows us to see things at a scale so tiny that they're invisible to the naked eye. But the implications of the uncertainty principle don't stop there. It's also key to understanding phenomena like quantum tunneling. Now you might be thinking, quantum what? Quantum tunneling is a quantum mechanical phenomenon where particles can pass through potential barriers. This is crucial for the operation of quantum computers, the next frontier of computing technology. These future machines could revolutionize everything from weather forecasting to drug discovery, and it's all thanks to this seemingly obscure principle. So when we ask why the uncertainty principle matters, the answer is simple. It's not just about understanding tiny particles in some distant lab, it's about understanding our universe, our daily lives, and the future of technology. So, the uncertainty principle isn't just about tiny particles in a lab, it's about the fabric of reality and the future of technology. Quite a big deal for such a small concept, don't you think?